much. Okay, a few things. We will have a quiz tomorrow. So there's going to be part that's pencil and paper and part that'll be on the Schoology, on the Chromebooks. We'll make that work. That's what I have planned. So is everyone good with problem number 1? Problem number 2?
Sir.
Yeah,
Anyone need me to work it?
Sir.
Work it?
Wait, we went over all of them. 2, 4, 6.
Okay, so
8.
we need to do number 3, right?
Sir.
We didn't do 1,
Number
3, 5,
7.
7,
Sir.
9, 11.
Number 7.
Okay. I will go through all the odds, which 7's
number 10.
included.
And number 10.
And number 10. Okay. A couple of you are a little too anxious right now, so cool down a little bit. All right, so I have 2 different denominators, and I have 3 different terms. What's the smallest number that both those denominators go with?
6.
Yeah, so I'm going to multiply this by 6 over 1. Is 6 over 1 the same thing as 6?
Yeah.
So I'll just multiply this by 6 rather than by the fraction. So that's 2, that's 4x. Agree? And then that's 3x.
Yay.
Agree?
Yeah.
Yep.
Combine like terms. Divide by.
7.
Wind up with 6 for an answer. Cool? Going to number 5. Squeeze number 5 right there. 3 over 4 minus 1 over 3z equals 1 over 4. All right. What's the smallest number that 4 and 3 both go into?
12.
12. I like it. Multiply by 12 over 1.
Yes, sir.
All right. 4 goes in there 3 times. So what do I have right here?
9.
9. 3 goes into that. So what do I have right here?
4.
And make sure you keep that minus sign. And 3. We good?
We're good.
Try Wait, what?
We're all right?
Yeah.
Sir.
A couple of you I'm going to have sit in the hall here in a few minutes. And if you have to sit in the hall, then you got to go call mom and dad and let them know that you're misbehaving in my class. Yes, ma'am?
For number 3, why'd you multiply 7 by 6?
Because that was 6 over 1 as well. 6 over 1 is the same thing. Because I have 3 terms. When I multiply, I can't just multiply 2 of the terms. It has to be all 3 of them.
I think it's a different way.
Did you get the same answer?
No. I got 1 as my answer.
Oh. Did you try and add the fractions together?
No, so I multiplied 2 by 2, because 3 times 2 is 6.
Uh-huh.
And then I did 2 times 3, so then
Did you
x
keep
was
those?
3.
Did you keep those over fractions still?
No. Oh, I see what you're saying now. Never mind. I just didn't multiply the 7.
Sounds good. All right. Subtract 9
-6.
and divide by -4 is you, my no neighbor. Yeah, baby. Okay, it cancels, and negative over negative is positive.
3
What is
over
that?
2.
3 over 2. Good, so make sure you reduce it. All right, can I move on? Problem number 5. 3 over 4? We just did number 5, didn't we? Okay. Problem number 7. 2 over 3x minus 5 over 8. Excuse me, x equals 2. What's the smallest number that 3 and 8 both go into? 24. So I'm going to multiply all 3 terms, because there's 3 terms up there, by 24 over 1, or just 24, if it's just a number. So 3 goes into 24 8 times. What do I have right here? 16x. Good. This goes into here. So what do I have here?
Negative 15.
Negative 15x. Good. And then over here I have 48, I believe. So 16 minus 15 is 1, so I get 1x equals 48, which is the same thing as just x equals 48. Yay? Okay, on the back side. Number 9. Well, I got to go number 9 first, correct? I didn't work 10 out? I
Are
didn't.
we going all
Yeah, because I did all these. What?
We didn't do number 10 yesterday.
Okay, but we did all the evens except for number 10?
Yeah.
Okay, so I'll make sure I cover the odds and number 10. Is that right?
Yes.
Alright. A 1 over 2x plus 3 over 2x equals 20. What should I multiply all three terms by?
2.
2. So what about if I multiply by 4? It still would come out, it's just you'd have a bigger number to divide at the end. Okay, so that gives me negative 1x. That gives me plus 3x, and that's 40. So that's 2x equals 40, I believe. X equals 20. Sound good?
Yes.
Okay. And then number 10, you said I should work out because I didn't do it yesterday?
Yeah.
Okay. 2a over 5 plus 3 over 10 equals 15 over 10. What's the smallest number that 5 and 10 I'll go into?
10.
10. Okay. And all three terms I'll multiply by 10 over 1 because all three terms are a fraction. Alright, so 5 goes into 10 twice, so I get 4a. Goes into 1 plus 3, that's an a. Equals 15. Subtract 3,
4 equals 12.
and so a equals
3.
3 because I divided both sides.
Wait, so on the test, do we like need to show like dividing by 4?
So I've been skipping steps, which is fine. Like if you showed me that, I could see a pretty good thought process taking place. It's the student that goes from the blue problem to a equals 3, and there's nothing that took place. That becomes tough. It's like, well, I could do it in my head. A lot of these, if you do in your head, you might be in the wrong math class if you're able to compute these that quickly in your head. And I realize there's some steps that we could see and go through, but we'll get to some bigger problems where it's like, there's not a math teacher in this building that could do it in their head, so pretty sure the student won't be. But who knows? You might have that kid who's the prodigy of math that we've just discovered. I had a student many years ago when I was teaching. He was in a really low-level math class. I mean, the kid couldn't add fractions to save his life. But he's one of those kids where it's like, okay, you have 38 coins that equal $12.55. They're nickels and dimes. How? He'd be like, boom, boom, done. He would say it to you, he's on his head. And then he could tell you if problems could or couldn't be done, and it had to do with money. The guy just had like this gift of knowing money. I don't know what kids doing these days. I don't know what I'm telling you. I'm just telling you. All right, what number does 4, 3, and 6 all go into? 12. Some of you might be saying 24. 24 would work as well. It's just you'd have a bigger number to divide at the end, but get the same answer. So we're going to multiply all four terms by 12 over 1. All right, 4 goes to 12 3 times, so you get a 9x. That's a 9. And then 4, that's negative 3x. And that's 20. And that's 2, so that's 50. Feel okay? Combine like terms, so that's 6x. And I can subtract 20, that gives me 30. So I combine like terms and I subtract the 20, then divide each side by the 6. There we go.
Wait, for 13, I got like an Ollie huge number.
Okay.
Is that fine?
13?
Yeah.
I don't know, I haven't worked it out yet. We'll figure it out though.
Maybe
Here we go.
everyone did.
Number 13. 2x minus 1/2 x plus 2 equal, that's it. Minus 9 over 4x equals 52. What should I multiply all 5 terms by?
4.
4. So that's by 4, the 4 over 1, 4, 4 over 1, 4. That gives me 8x minus 2x plus 8 minus 9x
Equals 208.
208. Okay. That's 6x. 6x minus that's negative 3x plus 8 equals 208. Subtract 8. Divide by -3. That works. Yo.
Okay, so I subtracted 2x and 9x first, and I got 1x. So
Oh, I see what you did. Okay. You subtract these two together, that gives you -11x.
oh yeah.
Does that change you? All right. Make sure your name is on these, and pass them on forward. All right. So problem number 1. Can somebody start talking you through how problem number 1 would go? Distribute? Okay. So 5x plus 35. Stop me if you have a question. What should I do next?
Minus 35.
Subtract 35 from both sides. 2,795. What should I do last?
Divide by 5.
Divide by 5. Does 2795 reduce into 5?
Yes.
Uh-huh. That would be 5. Oh man, someone on a calculator. 2795 divided by 5. 555.
I think it's.
So on the calculator, 2795 divided by 5.
Oh, it's 559.
559? Oh, okay.
That makes sense. I was close.
There we go. Is that all right? Wasn't sure how the headbutting his water bottle and knocking it over is related to math, but I might be wrong.
It's gravity, and we are seeing how much gravity is.
I'm not talking to you. Oh,
Wait,
gosh.
are we doing part?
I don't know. See how far we get. All right. Shh. Problem number 2. Somebody else tell me what I should do first. Yeah. Uh-huh. So I'll distribute over the parentheses.
Plus what?
Everything okay? No, I don't act like you're doing something right. You're chatting back there. You guys are passing stuff around. I don't know what's going on.
It's not homework that I just made you, so I'm just confused.
Did you give me homework just now?
No, like the one I handed you.
Why do you have that?
It just got passed from over there. That's why.
Guys and girls, this should not be the most difficult thing to pass homework forward. There's a couple of you that are off task way too much. I have no problem inviting your mom and dad to come sit next to you during my class. I will not allow you in my classroom if you want to screw around. You're here for math. A lot of people are here to learn. It's not fair that you want to take it away from people. You don't want to be here? We'll bring your mom and dad in. They can sit right next to you and show how well you're behaved in class. Got it? When I say pass homework forward, someone's homework shouldn't go to the back of the room. Think about it. The majority of you are 100% on task, and I thank you so much. The few that aren't, I'll get you out of here. We'll find you a new place to be. Because you don't need to have to be in this class. Got it? Someone have a problem with what I'm doing? Happy to sit down with you, your mom and dad, and your assistant principal that represents your alpha. Sound good? Happy to get you a behavior plan. Help me out. We did distribute. I like it. Thank you. Where do we go? At 12. Last step. Divide 5 by 6. So t equals 5. Is it okay if I flip-flop it like that? I like it. So this is kind of a little bit of a review towards what we're going to see. Can I go to number 3 and 4? Let me write them up. Why don't you guys try them real quick, and I'll have write them up on the board. See how we do. While you guys are doing that, let me go a little bit further. Okay, problem number 3. Help me out, somebody. Somebody who hasn't answered in a while. Yo.
So you distribute 4 over,
Distribute 4 over the parentheses. Perfect.
and then
Hang on. Let me catch up. Well, that's an equal sign.
I have a question.
Yeah.
If we know right away what like the answer is to this kind of problem, can we just write it down, or do you want us to show it? Because I know that this is no solution.
Oh, okay. So you saw it right away?
Yeah.
You know, for the most part, a lot of people will see that right away. Some people might not, which is okay. So this is one of those goofy ones. So no solution. Okay, no solution because all the letters fell out. Goofy answer, right? Yo.
Can you just add 6n onto the other side?
Sure.
Far away, Jacob.
I would have subtracted 6n, then you would have gotten 0 equals 20 as well. Huh, that's a goofy problem. So, things to think about on this kind of problem. If you were to have graphed 6n on a graph, it's a line, and then you could also graph 4 and then parentheses n plus 5 plus 2n. If you had graphed these two lines, you actually would have come up with 2 parallel lines to each other if you had used a graphing calculator. The parallel lines don't cross, right? If parallel lines don't cross, how could you have a solution if they don't cross? The solution is where they intersect each other. Problem 4. Help me out. Talk it out.
Wait, for sure, bro.
Yeah.
But if you wanted to graph it, doesn't it have to be like a linear equation?
This is actually a linear equation equals a linear equation. So you're setting 2 linear equations equal to each other. We don't have it as y equals and y equals. So we don't have x and y. But on the left side, 6n, if you graphed y equals 6n or y equals 6x, so your calculator would accept it. And then you were to graph y equals 4 parentheses n plus 5, close parentheses plus 2n. It would come out to 2 straight lines that would be parallel. And that's what's happening. So that's just kind of a glimpse of where we're going to get to, because we're going to start graphing linear equations. But we're not there yet. Distribute the negative over. Where do you think the error would take place here?
The taking the sign.
Yeah, people are like, okay, there's nothing here. Well, there's really a 1 there. So you're distributing that. So I want you to recognize this and this. Notice how they changed from above. That's a big spot where a lot of errors do take place. From there, let's combine like terms. Subtract the 15. Another place errors take place. Students get here and they panic. How should I solve it? What's really taking place on both sides? Yeah.
divide by -1.
Yeah, divide by -1 or multiply. This would be the same idea. So it just gives you this. A lot of times I've seen students like, oh, well, let's just kind of erase this one here and we'll leave the rest. No, you can't just erase the sign. It has to be there. Some math operation has to take place to get rid of the negative. May I move on? Okay, written number 5. Well, let's see what number 5 does for you. And the hint on number 5 is make sure you distribute over the parentheses twice. See how you did. been known to do that. Don't lose a point in that problem because you forgot to reduce. Questions on that one? Yeah.
I don't know what I did, but I got 3.3.
Let's see. What'd you get?
3.3. Because I had
Oh.
ended with 10x equals 33, then I divided it by 10.
Let's see.
So that equals, it's 15.
So do you agree with me to this step by chance? Are we okay there?
Yeah, I know what I did.
Okay, cool. Everyone else good on this one? Yep.
Okay. I was gonna say, if we don't get to number 9, we can still.
I bet you we will. I'm rolling the dice on this one. I bet you we're solid though. All right, go ahead and try number 6 and 7, and I'm gonna put a few more problems up. So 6 and 7 are already done. I'm gonna just write up a few more. Excuse me. Picked up myself a little cold of some sort. Yeah, it's all right. I think I'll make it through this time. Number 6. Should I distribute over the parentheses the half?
Yeah.
What's another way I could approach it?
Multiplied by 2.
Yeah, I have two terms up there. I have one of my terms is 1/2 quantity 2y plus 5. The other term is 7. So if I multiply this by 2 over 1 and this by 2, if I distribute 1 over the parentheses, I get this. Does that seem okay? Subtract 5. Again, I want the improper fraction.
We
Okay.
written 4.5.
You? Sure. All around you? No. All right. Yeah. If you put an equivalent form of the answer up, that's fine. It's just, I'm telling you, it's more accepted to leave things as improper fractions. Question? Okay. Number 7. Let's distribute here and here. Infinite solutions could be the. Did you find one of those? Yeah. Oh, it's coming up. It's not on 6 or 7. If it was, I did something. May I move off 6 and 7? Or is there any questions on those? Number 8. What should I do over the parentheses? Yeah, distribute. Yay or nay? Number 9, I should distribute over the parentheses here. Combine like terms. Subtract 2b, or subtract 20, doesn't matter. So I get 20 equals 20. So that means you have infinite solutions. That's a true statement. If I had graphed the linear equations using a graphing calculator, changing out your b value to be x, and you graphed y equals 2b plus 20, and then you graphed y equals 4 quantity b plus 5, close parentheses, minus 2b, the graph would have been 2 straight lines right on top of each other, like that. And that's how you know it's infinite solutions. They touch each other an infinite amount of times. Yeah? 2b equals 2b is going to be the same exact thing, because what you could do from there is saying, oh, okay, I got to bring b over, so you'd subtract 2b on both sides, and all of a sudden you get 0 equals 0, which is another very true statement. So the infinite solutions will be a true statement. So a number equals itself, 0 equals 0, that's obviously a number. May I move on? We good? Feeling all right for this quiz for tomorrow? There's a quiz tomorrow. Pencil and paper will be part, and then the other part on Schoology on the Chromebooks. Big error on number 10. A lot of people will goof this up. What should we do?
-1.
Yeah, I'm distributing a -1 over the parentheses. Okay, combine like terms. Subtract 21. And then divide by the negative, so I get 15 over 4. That's reduced. Problem 11, error that would take place would be?
Distributing the negative.
Distribute the -4. A lot of people just distribute 4, they'll forget to bring the negative. So the whole thing, here to here. Combine like terms, so that's -3x plus 8. Subtract 4, or excuse me, subtract 8. So x equals 4 over 3. Feeling all right about these? Can I get to number 12? Did I get to the one that you would wanted to see?
Yeah.
Okay, sweet. And number 12. Ooh. Should I distribute the 2/3 over the parentheses?
Yes. No.
I could, but I don't like the fraction. So what should I multiply? Right now I have 2 terms up there. One of my terms is 2/3 parentheses 4 minus y. The other term is 12.
3 over 1.
Multiply both sides by 3 over 1. Good. Or just 3. If I do that, that cancels. That gives me this, just so you can see it. Some of you might have skipped that step. So you have that 2 there, and then distribute over. I do that right? And then divide by 8. (50/8) is not a good answer to leave.
25 over 4.
I like 25 over 4. What do you think? Yeah. Do the 2/3? Okay, so let's do that. I totally could, okay? So that's going to give me 8x over 3 minus 14 over 3 equals 12. Okay, so that reduced to 3 over 1. 1 times 2 is 2. Is that right? Yeah, I just want to get the denominator. I didn't flip-flop the fraction. I didn't multiply by 3 over 2. I multiplied by just 3 over 1.
Wait,
Yeah.
So then
what's the thing in which you like multiply by the reciprocal?
copy out flow.
So multiply by reciprocal could be divided by fractions.
I don't remember. Like,
Or
it was,
divide-
I'm pretty sure it was like a multi-step equation. You used it. I'm not sure what it was used for.
I wasn't dividing fractions at all. in that one?
I don't know. I'm not sure.
Or the reciprocal. Some of these could have been reciprocal. Oh, I think I know what you're talking about. So if you had like this, something like that.
Yeah.
So I could, let's do this the first way. I could totally do it that way, or this could be done this way. Multiply by 3 over 2 and 3 over 2. So that gives me x equals 54 over 2. If I multiply that out, which is 27. So there's two ways of going about it. One way you could do the clear denominator. The other way is you multiply by the reciprocal of the fraction. That makes sense? I think that's what you asked. Cool. How do we feel? Word problems. Oh yeah. Word problems. Flip side, back side. Front side, everyone feel good? All right, you're definitely going to see some word problems tomorrow, similar to these. So number 13. 12 is equal to. So what do we know? 12 equals. Anybody stuck at that point? To the sum of half a number and 3. What does sum mean? Addition. So the sum of half a number. How do I do half a number? 1 half x or x over 2. Can I do that? 1 half x is the same thing. And 3. There we go. How do we solve that? I can subtract 3. I have 3 terms. How could I get? Yeah, I could. A couple ways I could do it. I could go through and multiply everything by 2. And then subtract 6. So x equals 18. Or flip it over. Or you could have subtracted 3, which would have given you 9 over here, which gives you that. That would have been if I subtracted 3 and then multiplied by 2. And lo and behold, the exact same answer. Which way is the right way? I don't know. Some people's brains are going to make one way work a lot better than the other. Cool. May I move off? Number 14. What does it say? 6 plus 4 times the number is 22. How do I write is 22? Equals 22. Good. 6 plus 4 times the number. 6 plus 4 times the number. 6 plus
4x.
6 plus 4x. Okay, subtract the 6. No, shoot. 16, sorry. And then divide by 4. Done. Number 15. Oh my gosh. I think number 15 might be just bad English. Bad grammar. 3 less than 4 times the number is. What? Darn math people had to pervert English into a bad thing.
4x
3 less than 4 times the number. 4 times the number is?
4x.
Now on 3 less than that is something. Add 3. Divide by 4. Okay. You're going to see something very similar to number 16 tomorrow, and it's going to be on the Schoology section. And it's going to say, hey, where was the mistake made? And you have to go through. Now, it's very possible there's no mistake, so that's one of the answers. And as you go through, it's going to progressively go. Yeah? She didn't what?
Do 5 times 1 is 30.
Oh. So right here, That's where the mistake was made, right? Sweet. Does everyone see that? See, find the mistake on there. And what you would have to do is like, this would be like letter A. And then letter B, they might actually go through and have the whole problem worked out where the mistake had started right here. And on ours, there's not a mistake because we did it correctly. But you have to be careful. So as you go through the problem, you know, what are some places we've said mistakes do take place? Distributing a negative is a huge thing. I've talked about it a lot. Do you think that might be something that we might see tomorrow?
Yeah.
Is it the problem on the test there? I don't know. There might not be an error. Hey, if I get one number is equal to itself, all the x's and letters fall out. Well, I got 7 equals 7, what does that mean? Infinite solution. If I get something really weird like, negative 7 equals 8, that's nonsense, right? So negative 7 equals 8 means what? No solution. So I want you to hang on to those sheets. Yes, we did it together. Yes, I will put it in the grade book because you all did it with me. I'd like you all to put a top mark, but I don't want to collect it. The reason I don't want to collect it is because this is recorded. That's a pretty good review. Yesterday's was a review as well, and that's also recorded. So you know what we have coming up tomorrow. Some of you are doing so unbelievable in here. We have like a class average of like 89% in here. That's awesome. Like seriously. Dude, let's totally keep that up. I think we can. So some of you have asked, am I available for help? And the answer is yes. Okay, I'm available first period over at 439A. Third period, fourth period. Sometimes in fourth period, I might have Pre 101. That's usually Mondays. Today though, no, tomorrow. Today we're in the theater, right? So first part of fourth period, I won't be in my office. The second part, I will. And then someone asked, what about 7th and 8th period? Yes, I am available, but I'm in an office over there. So sometimes if you came over, I might be in a meeting because my job over there is not necessarily just working with students in the math office. So for the most part, your best way to get a hold of me is first period, before school on Fridays, first period, third period, and fourth period over there in 439A. Yeah. Study. Cool? Yeah.
101, is everyone in the fine arts leaders in there?
Yeah, everyone should be. If you have Creek 101, even if you have it on Thursday. Not chilling off, Fine Arts Theater.
We just go there during our lunch period. Right?
Yeah, don't bring, you will get out quick enough so you won't have to bring lunch. You can't eat in there, so if you show up with lunch, I'm not going to let you come in with your lunch. So, I mean, just go if you buy lunch, throw it in your bag, come in, chill. It'll be probably about a 15-minute presentation, then you get out.
Oh, so that's even better than actually.
Is it like the principal talking to them?
Yes, Mr. Silver, he's a really fantastic person. And cares so much about you guys. So, it'll be a good thing. Any other questions? I guess I can stop recording. We don't need all this on there.